A little bit about OpenSciEd. We're an innovative nonprofit organization, and we bring together world-class curriculum developers, state science administrators, teachers, and philanthropic organizations, and we work together and collaborate to create free, high-quality, NGSS-aligned science instructional materials and outstanding professional learning experiences. So we really work through collaboration with all these entities. We're very lucky to have a wonderful consortium developing our high school materials. So Kate is here from the University of Colorado Boulder. They're actually leading the project and also leading biology. We have BSCS Science Learning, Next Gen Science Storylines, and then the Dana Center at the University of Texas Austin is doing our field test data analysis so that we can look at what's happening in classrooms and then revise the units based on what we see in the data. We have also 10 partner states that work with us in this. So these states are giving us guidance along the way, talking about what's going to work in real classrooms in their actual states. And so we're really grateful for those partnerships. And they also recruit the field test teachers that work to test out these materials and give us feedback, and so that we can revise them and make them better. So these field test teachers are coming from those 10 partner states, and they are doing such important work, testing out not fully baked materials, giving feedback on it, and helping us make them be something that works for all students across the country and beyond. And as part of that, we are touching and interacting with lots of students in this. So we have 19,000 students that were taught the field test units, and then we collect data and student work from 1,200 of those students. And this is really an important feature of our materials, is that we're actually testing them out with students and then revising and refining based on what we see in the student work and in their interest. An exciting thing for us, it's now a month old, but we're still very excited about it, is that we received a green rating from Ed Reports on our middle school materials. And this is important for you all just to know that the process that we used for middle school resulted in this high quality materials based on Ed Reports. We're using the same process to develop our high school with this feedback from multiple stakeholders and the review for quality. And so we're really confident and excited that our high school materials will also get a green from Ed Reports. So that's a little bit about OpenSciEd. I'm going to give some fast facts about OpenSciEd High School. If you attended the other webinars on physics and chemistry, some of this will sound familiar and you've heard it before. And this will hopefully just kind of give some framing and answer a lot of questions that people might have about our program. So one is, we are designing these materials to address the framework and the NGSS. We have a set of design specifications that help to really define how the materials can make that framework a reality. So if you're ever interested in it, it's 100+ pages of how do you really take that vision and make it live in instructional materials. And it's also just a really great resource. Every one of the high school PEs is going to be addressed throughout the 3 courses, and we've decided based on stakeholder input and like those 10 partner states and beyond, we've decided to do 3 courses. All of our materials are following the OpenSciEd instructional model. So this is similar to what we see in our middle school materials and soon to be our elementary materials. So everything follows this instructional model. We'll talk a little bit about it later on as we're experiencing this anchoring phenomenon as part of the unit. The big thing here is that we're eliciting student questions, and we're using those questions to drive the entire unit. Students are then thinking of investigations that they can do to gather data to help answer those questions. And this is why our field test is so important, because we're wanting to make sure, did we elicit the questions that we needed in order to be able to make this path go? And did the students think of the investigations that we thought they were going to think of? Did this work? Were they interested in this? And this is why our field test is so important, so that we can check that it's actually working with this instructional model. A few things about the course design. We took the all of the standards for high school, which are not divvied up or bundled into courses, and we divided them in a few ways. We took all of the life science unit, the life science PEs, and put them in biology. And then we determined how to really sequence the chemistry and physics courses. I'm going to show you what this ends up looking like. So life science went into biology, physical science went into chemistry and physics, and we did a lot of work determining which one of these went into physics and which ones went into chemistry. We took the Earth and space science standards and intentionally embedded them into these courses. This was not an afterthought. This was actually an intentional incorporation so that we could really use them to elevate the learning in the courses and kind of provide the phenomena and the events for students to be making sense of. And then we also incorporated the engineering, technology, and science applications into these 3 courses. So we ended up with these 3 courses that are a mix of all of these domains here. And we did design them with an intended sequence of courses. So we provide guidance for teachers and students for how they can build across all 3 dimensions when we're thinking about within the course. So from unit to unit, and then also between courses. In order to be able to make those connections, you do have to have an intended sequence. And so this is what we are designing for, is that it would be biology, then chemistry, and then physics. And there's also connections being made to, if students had the middle school program, what they could draw on if they did have it. Teachers could draw on those experiences. We also provide guidance for if you need to do this in a different order, or you need to change up the order of the units within biology, how might you go about doing that? But this is the design that we built with. I mentioned this before, we were really intentional with how we attended to the Earth and space science standards. They're really central to the units, and in many cases, they provide the authentic phenomena connected to students' lives. And we utilize the physical or life science concepts to then address these concerns of local and global significance. So the way we went about this was really intentional, and I think resulted in some very exciting units. And then another fast fact about high school, we really have this development being informed by student and teacher voices. So as I mentioned before, we have all these student and teacher voices that were part of the field test as we were field testing the materials. We also do some work to really gather student voice before we even start writing. So before we start writing a unit, we do these interest surveys, these student interest surveys. And I'm going to give you just kind of an example of what this might look like for chemistry. We did this for every course in every unit. So in this case, we have, for this unit, there were a series of topics that could have worked for the unit. So in this case, there was one topic was lightning, another topic was batteries. And for this, we asked students, was this not interesting at all? I have no questions about this. Or was it very interesting and I have lots of questions? And we sent this out to thousands of students and asked them to respond to this. And then we looked at the data by a variety of attributes. So, and here's the survey participants for this particular survey. We looked at overall interest. So for this example, all you need to know is green means good. And so, and yellow and red means not as good and not as interesting. So in this case, these students, this is all of them that responded. They found that lightning was more interesting than batteries. We also look at it by where they live. So rural, suburban, urban, you see that still lightning was more interesting than batteries. We looked at it by gender, lightning, still more interesting than batteries. We looked at it by race and ethnicity, and lightning is still more interesting than batteries. And this is what we do for each of our units, is we're thinking about the student interest and actually asking students what's interesting to them and making sure that we're not making assumptions, and also looking at the different subgroups and making sure that it's interesting to all subgroups. So those are some fast facts about our high school program. And